Okay, so I'm going to get back to this proving a quadrilateral is a parallelogram. So the only way you can prove a quadrilateral is a parallelogram is using the definition. Now, there's other theorems we can use that allow us to use those properties to conclude it's a parallelogram. So when we learned in 7.2 about the parallel opposite sides theorem, well, you have a converse. If both pairs of quadrilateral are congruent, then it's a then the quadrilateral is a parallelogram because it meets the definition. Okay, so this theorem, if you flip it around so that you have both sides congruent, then it is a parallelogram. Okay, we're going to do a little proof. Like I said, I'm going to talk through it for a second just so you can follow all these steps. It's one of those long ones, that's why there's lots of space here. But basically what I'm going to start with is I'm going to say that AB is congruent to CD. I'm also going to say BC is congruent to DA, and I'm going to prove that it's a parallelogram so that you know that this is valid. Okay? And again, we're going to keep practicing on proofs till the end of the year. So we'll see how this goes. All right, so number one, we always know that we're going to do our givens. So AB is congruent to CD, BC is congruent to DA. Now I'm going to ask, does anybody remember how I had this same shape and I did a proof in 7.2 where I did something with this to make it into two triangles? What was that? What do I want to draw so that I get? Say that again, I couldn't hear you.
You put a line through it.
Exactly. Thank you. I'm going to draw BD. Very good. Because from here to here, right, through any 2 points, there exists a line. And thank you for speaking up. Now, I have this line, and you know my goal, of course, is I'm going to try to prove that the triangles are congruent. So the easiest thing to do is to say, well, BD is congruent to DB because it is reflexive. That's the reflexive property theorem. Congruence. All right. So now do you see what I have? How can I say that those triangles are congruent? Triangle ABD is congruent to triangle CBD. Why?
Side.
That's it. All three sides are shown. So this is a congruence theorem. Yeah. Perfect. All right. Now, every time I get congruent triangles, then I can use corresponding parts, right? Well, if I want to show that this is a parallelogram, then, well, now I have corresponding parts. Corresponding parts of congruent triangles are congruent. Of course, the trick is here, well, which parts do I want, right? Okay, the parts that I want here are, I'm going to say angle ABD is congruent to angle CBD. So I'm going to get this one here. This one here. I wish I had a different color. All my pens are running out. I have to actually put my mask on and go to the store and get another one. But okay. So now that I know those triangles, the angles are congruent. Now I can say that BC is parallel to AD. Remember, the definition of a parallelogram is that the opposite sides have to be parallel. Why can I say this? Because these are alternate interior angles. So if alternate interior angles are congruent, then I get parallel lines. I don't know if you remember that or not, but it's the converse of the theorem we've been using. And then 7, I can do almost exactly the same thing, right? But now I'm going to do a DB is, so a DB is congruent to ABD, wait, I think I miswrote this one. So CBD, so this is ADB. Yeah. Sorry about that. We all make mistakes. That's why I love pencils. ABD, okay, so now ABD, that's why we have to be careful about how we write it, is congruent to CDB. Okay, now I'm good. CDB, and that's the same reason. Corresponding parts of congruent triangles are congruent. And so now I can do the other sides parallel. So let's see, BA is now parallel to CD. If alternate interior angles are congruent, then parallel. And finally, now I can say that ABCD is a parallelogram. And I'm going to have to put the 9 over here, sorry, because I have met the definition. So definition of parallelogram. Again, going through this proof, you see that what we've been doing all year is coming together. Whenever we get a theorem, we can usually prove its converse, so it goes both ways. We're using all the different things we've learned all year, and hopefully the more you follow along, the more when you practice on your own, you're getting better at it. Okay. This one down here, number 1, when I printed it, it cut off right here. I don't know if yours cuts off, but on this x plus 9 is equal to 2x minus 1 down here on the bottom. And so all we have to do, you know, if we want to know what values these are, is solve it that way. Let me get this out of here. So we know they're equal. So x plus 9 is equal to 2x minus 1 from those two sides. And then this one is y equals x plus 7. So we pull out our algebra, we solve for x here, and then we'll solve for y here. So I'm going to take away an x from both sides, and I'm going to add 1 to both sides to get 10. And so if x is 10, then y is going to be 17. So the actual types of problems are really, you know, fairly straightforward with parallelograms. That's why they're kind of fun. But this proof is important. Any questions right now before we turn the page and do a second theorem? Okay. So we're going to revisit some more theorems from 7.2. So we had opposite sides. Well, it makes sense also that we have opposite angles converse, right? So that was the second one. If both pairs of opposite angles are congruent, then it's a parallelogram. So it's exactly the opposite. Now if we get the opposite sides congruent, we're going to get a parallelogram. Now, the proof is, you know, if time permits, it's a slight bit involved, just like the one we just did, but it's extremely similar. It's almost all, it's almost the same, but I'll put it on the website. Actually, not the website, but the notebook, right? I'll put it on our digital notebook if you're curious, okay? But if we know that this converse works, we can solve these kinds of problems. The big angle here is equal to the big angle here. And this, no, whoops, big and big is equal to, and small is equal to small. So we're just going to solve this. 3x minus 32 is equal to 2x here. And then the big ones, 4y equals y plus 87. All right, so let's see, I'm going to take away 2x from both sides to get x here, and then I'm going to add 32 to both sides to get that. On this side, I will take away 1y to get 3y on here, and it's 87, and is that 29? See, 3 goes into there twice, 6 with a remainder 2, so 29. Of course, use your calculator or your phone, whatever's nearby. And that's how you do those types of problems. It's very much a natural progression past 7.2, which means this one's going to be different than 7.2. Those two follow directly from 7.2. This is another way to define a parallelogram, or how to prove it, because it sort of forces a definition here. So if you have opposite sides, just one of the opposite sides, okay? So, you know, in this example, it's BC and AD, but it could also be BA and CD. So if they're congruent and parallel, you have to have both. Okay, it has to be the same side. It can't be these congruent and those parallel. Got to be the same side. Then you can prove that it is a parallelogram. Okay. So this is one more tool in your toolbox. I'm going to go ahead and run through the theorem. Okay. And just as I do this, remember, you can use any past theorems if you already proved as reasons. So you can make sure that I'm going to do that. It's going to be very similar to the last one. I'm going to start with these sides congruent and BC parallel to AD. So that's what we're given. And we're just going to try to prove that A, B, C, D is a parallelogram. So that means we need both sides parallel. That's where we're going with this. We have one side, we need the other. Oh, parallel and congruent, really. But all right. So again, we're going to draw BD. You should see a pattern here by now. We're going to prove that those triangles are congruent. We're going to use corresponding parts. And then once that's corresponding, then we can say that those sides are congruent. So same strategy as we've been doing. I'm hoping that by you seeing it over and over and over and over and over again, it's going to sink in, probably without you even noticing. Okay, so from here we're going to say that BD is congruent to DB. This, of course, is the reflexive congruence theorem, or property. And then we're going to go for the angles. Okay? So I'm going to say that angle CBD is congruent to ADB by alternate interior angles theorem. I'm going to put that as a property. That's a property. Okay, now that we have those angles, and I have a side, and I was already given a side, you see what we have now? We have side, angle in between side, and we have side, angle in between side. So I'm going to now say that these triangles are congruent, by side angle side. And I can go in for the kill, which is what I said. ABCD is a parallelogram, and we need to know that it is, that if the opposite sides are congruent, if I can say BA is congruent to CD, then it's a parallelogram, which I can now because I got the triangles to be congruent. My corresponding parts of congruent triangles are congruent, which means I have met the definition that ABCD is a parallelogram because, here's the thing, if opposite sides are congruent, which we did in 7.2, then you get a parallelogram. Isn't that handy? I love it when a plan comes together like this. So go ahead and study that for a second. I'll give you, a couple more seconds to write that down. I know sometimes I go a little fast, and it's not always easy to follow what I'm doing. We still have, it's been almost 20 minutes now. I think I would like to do about 5 more minutes of notes. Okay? And then we will pick up tomorrow and do the rest of them, because you have enough to get started on this. But like I said, let me do those 5 more minutes, and then you'll have about 15, 20 to work on the problems. You won't be able to finish it today probably, but there is one more theorem. So we'll go ahead and get through that theorem at least, so you can get started. So then, for section 7.3, I told you there were 4 theorems, and then that chart that I'm going to put on here in a second. It's actually already in the notebook. So, in 7.2, we also learned that if you have a parallelogram, that the diagonals bisect each other. So, of course, we're going to have the converse there as well. If the diagonals of a quadrilateral do bisect each other, if you get that fact, then you know that it is a parallelogram. So that's the converse. I'm going to go ahead and write all this down because it should take me about 5 minutes. It's almost exactly the same as the last few proofs. Let me zoom out just a tiny bit, and then we'll finish the notes tomorrow on this. Because after this, you're probably fatigued. Your brain is going to be fatigued. But again, so what we have here is that JL is bisected by P, and KM is bisected by P. So let's write that down as our given. Diags JL, KM. Bisect each other. Okay. Now, I don't have to draw a diagonal here. But what I am going to do now is I know it's bisected, so I'm going to specifically say that JP is congruent to LP, and also KP is congruent to MP. And that's the definition of a bisector. You get congruent equal parts. So I now have this. I've also told you whenever lines cross and you get a chance to use them, look for vertical angles. So that's going to be our next step. We don't need alternate interior. We're going to look for vertical angles are congruent. So since I have them in here, all right, then I'm going to look at this one and this one. So that gives me KPL is congruent to MPJ. because those are vertical angles. And now I can say, what theorem can I use to say that these two triangles are congruent? Hopefully you can see it. Okay, I have a side here, I have another side here, and an angle in between. Side here, angle in between, and another side here. So it's going to be side, angle, side. Side, angle, side. Side angles. But thank you very much for volunteering. It's really helpful, if that's Annika, when you pipe up and give me a stab in the dark. Even if you don't know, I really appreciate you trying, because you're more often than not correct. You just need some encouragement. Okay, anybody else can volunteer too. So now that I have these two triangles, I need to do the corresponding parts. Okay? So what I want to show, or what the corresponding parts, is I get that KL is congruent to MJ. Corresponding parts of congruent triangles are congruent. So KL, right, the top part, is congruent to MJ, which I do have my yellow, I could do that. So now you have this. So I have congruence. Now I need parallel, okay, because the previous theorem said if I can prove alternate interior angles, if I can prove parallel and congruent, then I've got it. That's one of the definitions. Okay, so angle KLP, it's going to be up here, is congruent to angle MJP, so KLP, MJP, by, also by corresponding parts. And if that's the case, then I have alternate interior angles. Because I know that these are, and that gives me parallel. So KL is parallel to MJ. So I got congruent and I got parallel. So finally that means I can say that JKLM is a parallelogram, and that is the previous theorem that we proved. If one pair of opposite sides are congruent and parallel, then we get a parallelogram. That's a previous theorem we did on the first page. That's why we had to go in order there. Okay? From here on out, like I said, we'll finish the things tomorrow, but I'm going to include this, and I'll post this video on my YouTube channel and stuff so you can see it. But these are the 5 different ways. This is what this whole section's about. That's why we're taking 5 or 6 days on it. These are the ways to prove that something is a parallelogram. Okay, and so I wanted you to have this. I did also put it in the notebook, but I'll have to put a link to it so you know where to find it. It's in the content library. Tomorrow we will finish those notes up, and you will have the rest of the period to work. It is 9:05. Sorry about that for taking the entire period. I know it was heavy. If you have any questions, send me a chat. Otherwise, I'm going to go ahead and